So in this video, we are looking at our final method for solving simultaneous equations, and this is the process of elimination. We call this the elimination method. Now, in order to do this, we are, as the name suggests, trying to eliminate one of the pronumerals, one of the variables. So the steps here tell us that we want to, before we do anything in the elimination method, we want to make sure that the two coefficients of one pronumeral are the same. Now, if they're not immediately the same in the equation, it may require us to multiply or divide one or both equations by a number in order to get these coefficients the same. Next thing we're going to do is eliminate one pronumeral by adding or subtracting the two equations. So we'll be performing an operation with these equations in order to eliminate one of the variables. Then we solve the new equation to find the value of one pronumeral. So like substitution, this will give us a new equation with just one pronumeral that we can solve. And then the final step is the same. We substitute that value into either of the equations to find the value of the second pronumeral. Now, going straight into this first example, we are trying to eliminate one of the variables. Now, thinking back to algebra way back earlier in high school, we remembered that when we have just a pronumeral on its own, y and y, the coefficient in front of it, we always think of as being 1. So anytime you see just the letter on its own, we assume it already has the same coefficient. So basically, we've fulfilled step 1. It has the same coefficient. What we're going to do next now is we can subtract one equation from the other. Now, the order doesn't matter so long as you're consistent with each of the like terms and the order in which you subtract them. Now, what I'm going to do here is I'm going to take equation 1 and I'm going to subtract equation 2 from it. Now, what this means is that each of these will be subtracting. So I'm going to subtract y from y. I'm going to subtract negative x from 2x. And there's no other number down the bottom, so I'm essentially subtracting 0 from 3, which won't change the 3. Okay, so doing this, I'm going to get 0 on the left-hand side. We have to be careful with our negatives here, right? We've got 2x minus x, which when we have a double negative is the same effect as adding. So 2x is going to become, instead of 2x minus x, 2x plus x, which will give us 3x. And then the plus 3 remains. Now we just get a simple two-step equation that we can solve. So we can subtract 3 from both sides to get it away from the right-hand side. And I can divide both sides by 3, giving me that x equals to negative 1. Now that I have this, I can substitute into either of these equations, but like I said in the last video, we always want to go for the path of least resistance. So substitute back into the easier of the two equations, just to minimize the potential for us to make any mistakes. So we're going to sub into equation 2. So what we get is that y equals minus 1. And when we have a double negative, that becomes a positive, so y equals 1. Now, this is the solution to the simultaneous equations. For the second example, we notice that we have the same number in front of the coefficient of y, but we notice something different about this example compared to the first one. The signs here in front of the 2y are different, okay? So if we were to, for example, subtract equation 2 from equation 1, this would give us minus 2y, minus 2y, which will give you negative 4y. So it won't actually eliminate the variable. Because the signs are different, we want to add them together in order to eliminate this variable. When the signs were the same here, they were both positive y here, we subtracted. When the signs are different, we are going to add. So here, we're going to do equation 1 plus equation 2. And I'm going to add each of the parts. So 3x plus 2x gives us 5x. Negative 2y plus 2y gives us 0. So that successfully eliminates the variable. And 15 plus 20 gives us 35. Now we have a simple one-step equation. We divide both sides by 5. That gives us that x equals to 7. Now that I have my first pronumeral found, I can substitute into either equation 1 or equation 2. It will give me the same answer. Now, I'm going to go with subbing into equation 2 just because there's no negative sign, so it just will make it a little bit easier to calculate. But what I'm going to do is I'm going to sub x equals 7 into equation 2. And what I will get is 2 times 7 plus 2y equals 20. So this is going to give us 14 plus 2y equals 20. I'm going to subtract the 14 from both sides to remove it from the left-hand side. So I'm going to get 2y equals to 20 minus 14 gives us 6, and divide both sides by 2, giving me y equals to 3. So when the signs are different, just to reiterate, we want to add the two equations. When the signs are both positive, when they're the same, we want to subtract them. Now with our final example, we notice that we can't just off the bat see any coefficients that are the same. Now, you might say, well, 2x and 2y, that's the same coefficient, but we want the coefficient to be the same of the like terms. So we want either the thing in front of the y to be the same or the coefficient of x to be the same. So here is where we have to go to step one here, and where it says it may require multiplying or dividing one or both equations by a number. So what we're going to do is we're going to see how can we get one of the coefficients to match up with one of the other ones. Now, just looking at the y here, because it's on its own, we assume that the coefficient is 1. So it's really easy to get 1 to 2 by multiplying by 2. That will make equation 1 have a coefficient of 2 in front of the y. Before we can do any elimination, we need a pair of coefficients to be the same. So what I'm going to do is I'm going to take equation 1 and I'm going to multiply it by 2. So each part of my first equation is going to get multiplied by 2. So 2x multiplied by 2 gives us 4x. 1y multiplied by 2 gives us 2y. And 8 multiplied by 2 gives us 16. So you can recall this equation 1 if you'd like. You can call it equation 3 if you'd like. But just to make it easier, I'm going to call it equation 1 because it's an equivalent equation to the first one. Each part of it has just been scaled up by 2. Now that I have this, I'll write equation 2 under it just for ease. So you can see that when I write one of them on top of the other, we can easily identify what needs to be eliminated. So here, I want to eliminate the 2y. Now remember, it doesn't matter which order I subtract in as long as it's consistent with each one, but I'm going to do equation 1 minus equation 2. So here I have 4x minus 5x, that will give me negative x, and the 2y, that disappears, it's gotten eliminated, and then I get 16 minus 3. Remember, we have a double negative here. It's 16 minus negative 3, which is the effect of 16 plus 3. So that gives us 19. And negative x gives us 19, so we can divide both sides by negative 1 to give us x on its own equals to minus 19. Okay, so what we're going to do, now that we have this, we can substitute this back into really either this equation, or this kind of new one, equivalent one I've made for equation 1. But just by looking at it, I can see the path of least resistance comes from equation 1. So I'm going to substitute back into it. So I'm going to sub x equals minus 19 into equation 1. So I will get 2 times minus 19 plus y equals 8. So 2 times minus 19 will give us minus 38 plus y equals to 8. And solving this one-step equation, I want to add 38 to both sides to get it away from this left-hand side. So I'm going to get y on its own over here. And 8 plus 38 will give me 46. So I have a solution to my simultaneous equation. So with this particular example, it wasn't as easy as the other two in the sense that we had to multiply one of the equations by something in order to make a pair of the same coefficients. Once they are the same, only then can we eliminate. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.